Assignment 26, we're moving on to 6.3. We're going to talk about adding, subtracting, and multiplying polynomials, and then also some special product patterns. So in your essential question, I said, how do you perform operations? Everything except for division, so addition, subtraction, multiplication on polynomials, and then also what are the special product patterns? And you've already been introduced to some of these, but we'll review them, and we'll also look at some new ones. So starting with the easy stuff, example 1, we're going to add or subtract. Okay, so the first example gives you x to the 4th plus 2x cubed plus 8. That's one polynomial. Okay, it's actually a trinomial, right, because there's 3 terms. And then I'm going to add to that a binomial, 2x to the 4th minus 9. Okay, so right now these are in parentheses, and this is very important, and this is where I watch a lot of people mess up a lot of times. Not necessarily on this one, but on the example we're going to do next. You have parentheses around these 2 polynomials. It's important to realize, what is the number outside? Well, the number outside is 1, so I'm going to distribute that 1 in order to get rid of the parentheses. And I'm going to do the same thing here. Again, I have a positive 1, distribute that 1 in order to get rid of the parentheses. So if I'm just distributing 1, does anything change? No, of course not. So really now I have x to the 4th plus 2x cubed plus 8 plus 2x to the 4th minus 9. And now I need to combine like terms. So looking for like terms, I can see that I've got some x to the 4th, so I'll underline those once, and I end up with 3x to the 4th. I've got an x cubed that's all by itself, so I'll add that. And then I've got constants, right? Numbers with no variables. Okay, so we end up with, let's see, an 8 minus 9 is going to give me a negative 1. And voila, there it is. Not hard, right? Okay, so that one was super easy. Okay, so let's move on to the one that everybody messes up on. So I just said everybody messes up on this. So maybe you should asterisk it. Maybe you should put a big note next to this. Like, get a lot of repetitions, okay? Because I've been doing this for a long time, and I see this happen constantly. Okay, so there's our first polynomial. Okay, it's got 4 terms. And from that, I'm going to subtract my second polynomial. Okay, so again, I'm looking outside the parentheses to see what's out there and what's being multiplied to the set of parentheses. And really, there's just a 1 out here, right? So that's easy. I'm going to distribute the positive 1. How about the second parentheses, though? The second polynomial, there's a negative 1 out here. So I need to distribute a negative 1 to everything in the second polynomial. That's going to make each one of these terms opposite of what they are right now. Okay, so I'm going to have 9x to the 4th minus 12x cubed plus x squared minus 8. And now I'm going to distribute that negative 1. So when I distribute negative 1, I get negative 3x to the 4th, positive 12x cubed, and positive x. Now it's time to combine like terms. So I see some x to the 4th. So it's a 9x to the 4th and a negative 3x to the 4th, 6x to the 4th. I've got a negative 12x cubed and a positive 12x cubed. Those are gone. Don't even deal with them. Okay, next comes x squared. I don't see any other x squared, so I've got a positive x squared. Next comes x. I don't see any other just x's, so I've got a positive x. And then my constant, and I don't see any other constants, so negative 8. So there's my final polynomial. Okay, so again, this is where I watch everybody mess up. And notice these 2 polynomials are not getting multiplied together, so there should be no distributing from one polynomial to the other. There is a subtraction sign here, right? And so this is minus 1 times all of that. Okay, or basically you're just subtracting this second polynomial, and that subtraction sign needs to get distributed. Okay, I think I've harped on that long enough, so hopefully you don't make that mistake. But I keep harping on it because I watch it happen constantly even after I harp on it, so be careful. Okay, example 2. We're going to multiply. Now, we've already done this. We reviewed multiplying polynomials and specifically binomials, but let's just go ahead and review this again. So this time I'm going to have 3 binomials that I'm going to have us multiply. Okay, so the way that I do this is I always start with, the first 2. I mean, multiplication is commutative, so you could go in any order that you want, but why not just deal with the first 2 first? Okay, so when I distribute the first 2, right, you can think of this as FOIL, you can think of it as double distribute, you can think of it however you want, okay, but I'm going to distribute, and I'm going to get x squared minus x minus 2x plus 2. So all of that now will end up getting multiplied to x plus 3. But before I do that, so that I don't have to do too much distributing, I can combine like terms here. That's right, my middles, my outers and inners. Okay, those are like terms, so I can combine those. So I have x squared minus 3x plus 2, and I'll multiply that by x plus 3. Okay, so now I'm distributing, and it's up to you however you want to distribute. I'm going to start with this first term, distribute it to both terms in the second binomial. Okay, so I've got x squared times x, that's x cubed, x squared times 3, that's plus 3x squared. Okay, first term, done. Moving on to the second term, which is a negative 3x. Negative 3x times x, that's going to give me a negative 3x squared. Negative 3x times 3, that's going to give me a negative 9x. And then second term done, moving on to the last term. So I'm going to take the 2, multiply it to the x. It's going to give me positive 2x, and the 2 distributed to the 3 will give me a positive 6. All right, so combining any like terms, I don't see any other x cubes. I do see a couple x squareds. Oh, but look at those, they're opposites. Gone. I do see a couple x's, so that combines to give me a negative 7x, and then my constant, positive 6. All done. Okay, so let's move on to some special product patterns. Now, I think I'm going to, so I can put them all on the same side, I'm going to go ahead and flip over here. These help you recognize little shortcuts. They also will help you, if you can recognize these, they're going to help you be able to factor better. Because, for example, I'm taking out my friends. These are my factoring friends, okay? Going back to, for example, difference of 2 squares. Well, when I had a difference of 2 squares and I factored it, I ended up with a sum and difference pattern, right? So if I can recognize that I have a sum and difference pattern, 2 binomials multiplied together, same exact terms, opposite signs, then I know that my inners and my outers will cancel out. So all I need to do is multiply the first ones and the last ones. Now, this is not true all the time, and a lot of you guys will mess this up, okay? This is not true all the time. Okay, so let me go ahead and start the notes, and then I'll go back to when it's not true. Okay. So our first special product pattern will be the sum and difference pattern. So this is when you have, for example, a plus b times a minus b. When you multiply that, you're going to get a squared minus b squared. And the reason that happens, again, go back to your factoring friends, we've already proven this, the inners and the outers, when you FOIL, cancel each other out. So really you're left with a difference of 2 squares, which is exactly what I'm left with here. Okay, so if you want an example of that, I guess we could do, how about x plus 5, x minus 5. I'm going to end up with x squared minus 25. Okay, that's your sum and difference pattern. Okay, so a time when that does not work is when we are talking about the square of a binomial. And a lot of you guys will apply the same concept to sum and difference pattern as you will apply that to the square of a binomial. And that is not okay. That is very bad. That is going to get you a lot of points taken off of your tests. Okay, so be careful. So let me show you where I've got that. Okay, so when I have the square of a binomial, right, x minus 5 squared, look at what I get. I actually get a perfect square trinomial. That is because x minus 5 times x minus 5, the inners and the outers don't cancel out. The inners and the outers are the same, right? The inners and the outers are the same. Okay, so that means that basically I'm going to take whatever, well, basically that just means I can double whatever my inners are, or double whatever my outers are, okay, to give me that middle term, which ends up becoming a perfect square trinomial. Okay, so let's go ahead and define this. So, and I'll do them with both, oh, you know what? Wait, I'm going to go back to this. Let's call this what it is. If I were looking to factor it and looking at my factoring friends, this would be a difference of 2 squares. Okay, sorry, I want to make sure I define that, and I just remembered that. Okay, so square of a binomial, well, one example would be if I just had a plus b squared. Okay, so here's how you can do this quickly, or you can write it out and distribute, just like we did on our factoring friends, right? I have x minus 5 times x minus 5. That's the same thing as x minus 5 squared. What I've already seen some of you guys doing is just saying, oh yeah, that's x squared minus 25. No. Or x squared plus 25. No. It's x squared minus 10x plus 25. Okay? So, when I do this, what I end up with is that first term gets squared. And remember, the inners and the outers are going to be the same, right? So basically, you're going to multiply a times b, and you're going to double it in order to get your middle term. And then your last term is b squared. And the same would be true with a different sign, like subtraction, right? It'd be the exact same pattern. Only one thing's going to change, and that happens to be the sign of the inners and outers when they're combined. So it's minus 2ab plus b squared. Okay, so what you get here, these are, when you multiply a square of a binomial, you get the perfect square trinomial. Hopefully you're recognizing these names because these are your friends. You don't want to abandon your friends. Okay, so you really need to know them backwards and forwards, and that's basically what we're doing right now, right? Now we're doing the multiplication part. The factoring was we were looking at this and getting back to this. Okay, so we're going forwards and backwards with these. So hopefully you're really good with this. So I'll do one example. How about we do x plus 5? X plus 5 squared. Okay, so this is a binomial squared, or the square of a binomial. So I'm going to take my first term and square it. My middle term is going to be positive, and that comes from basically multiplying the two terms and doubling it, right? So that would be 5x doubled would give me 10x. And then squaring the last term. Do you have to do it this way? Could you instead write it as x plus 5 times x plus 5? Of course you can. But in the long run, if you can recognize these patterns, I promise you your life is going to be a little bit easier in math. Okay, so that's fine. If you don't believe that this is working, go ahead and, keep using FOIL or the double distributing. Okay, but definitely try and work on recognizing these patterns. Okay, now here's one you've never seen. Cube of a binomial. So I'll introduce you to what the formulas are, and we'll use them, but I'll also show you how to do it just by multiplying it out. And I'll show you how to use Pascal's triangle. All very exciting stuff. So if I have a plus b cubed, there is a pattern to this, okay? You can memorize this pattern. You can write it on your index card, okay? And then I'll also show you where those numbers come from. So when you do these, it's basically going to be the first term gets cubed. Now the second term has a coefficient of 3. And now the first term gets squared, so the first term has 1 degree less, and the second term has 1 degree more. So first term gets squared, where it used to be cubed, so 1 degree less. And there is no b here, right? So this is like b to the 0. So now b gets 1 degree more, or b to the first. Okay, next coefficient is also going to be 3. And we're going to do 1 less power of a, and 1 more power of b. Right, so there's a pattern here. The a's decrease while the b's grow on each term. Okay, the last term, a coefficient of 1, and then a gets 1 less, which is a to the 0, and b gets 1 more, which is b cubed. Okay, so that's if it's addition. This is if it's subtraction. It's the same exact terms, just the signs alternate. So you'll start with a positive a cubed, a minus 3a squared b, a positive 3a b squared, and a negative b cubed. All right, so let me do an example with you on that. Let's pick one that's not going to get too big. How about x plus 2? We could do 5. Okay, let's do x plus 5. Why not? Let's stick with the 5s. Okay, so I'm going to show you several ways of where this all comes from. I'm going to show you one using the pattern. Okay, so my first term gets cubed. For my second term, I need a coefficient of 3. So anytime you're cubing a binomial, that's the case. These are going to be your coefficients. Okay, the 3 and the 3. All right, so I'm going to add, let's see, so 3, and then the a, or the first term, gets squared now. And now b can come onto the playing field, so we'll times that by 5. Okay, I'm going to do the same thing, but, oops, not a, sorry. I meant x. Okay. Now I'm going to keep the 3. A, which is really my x, is just to the first power now. And now I'm going to multiply that by b squared. And that's my second term. So that's really 25, right? B squared. And then, and then I'm going to add b cubed. Well, 5 cubed is really 125. Okay, so now I'll simplify this. So this is going to be x cubed plus the coefficients get multiplied together. So that's 15x squared, 75x plus 125. Okay, so that's how you would deal with it. Now, worst case scenario, you don't remember the pattern. That is a worst case scenario. And you can always do this. It is the same as doing this. Same as doing x plus 5 times x plus 5 times x plus 5. I'm not going to do that because I don't need to, okay? I never need to do this. You can if you need to. However, let me show you one other thing. Let me show you where these coefficients come from. It's called, you can basically take any binomial to any power and you can expand it using Pascal's triangle. So Pascal's triangle, I have it on the wall in my classroom, maybe you've seen it at some point, is a pyramid. And it starts at the very top with 1. And this represents the coefficient for any x to the 0 power. Okay, so basically you get 1. All right, so the next one is going to be 1 and 1, kind of on the sides. And I'll go down this row in a second, but now here's how you get the rest of this. So basically you start at the top with 1, the next row has 2 1s kind of on either side of this one, and then the next row, it's always going to have 1s along the outside, but the next row comes from adding the 2 above. So that gives me a 2. 1 plus 1 is 2. And then I'm going to have a 1 on the outside. And the next row, again, 1 on the outside. Then we get these 2, add them together. And then take these 2, add them together. And then a 1 on the outside. Okay, so this is where I am right now. So this is if you have x to the 0. This is if you have x to the first, which expanding, you're not even going to expand those binomials, so you're fine. This is if you have x to the x squared. Okay, so this actually applies to the coefficients right here, right? Aren't my coefficients 1, 2, and 1? Isn't that like so cool? You don't even really have to do the math. There's your coefficients right there. And then a has a power of 2. The next term, a has 1 less. B has 1 more. And then the last term, a has 1 less, which brings it a to the 0 power, so there's no more a. And then b has 1 more to the second power. Okay, so now this is whenever you have x cubed or a binomial cubed. Here are the coefficients. So let me go back up to here where it's pretty simple. So the coefficient is 1, just like that one. This one is 3, just like that one. 3, just like that one. And then 1, just like that one. Okay, and then again, the powers of A are decreasing, powers of B are increasing as we go along. So what if I gave you x to the 4th power? Or some binomial like a plus b to the 4th power? What are the coefficients going to be in each term? Well, let's go ahead and let's do this pyramid one more time. So starting with 1 on the outside, add the 2 above to get 4. Add these 2 to get 6, add these 2 to get 4, and then you always end with a 1. So your coefficients would be 1, 4, 6, 4, 1. Okay, I'm not going to do that right now because I don't want to give you too much and I don't want to take up too much of your time. But this is the coolest thing. This is called Pascal's triangle. And it is used for binomial expansion. Okay, it's used for binomial expansion and many other things. The patterns in Pascal's triangle describe so many phenomenons in nature and all around us. Okay, moving on. Let's do example 3. So we are now going to use these patterns, these product patterns that we have noticed. So we're going to multiply. So the first one we're going to do is 3x minus 2 times 3x plus 2. Okay, now of course you can use FOIL. And if you are looking, you will notice that your inners will give you a negative 6x and your outers will give you a positive 6x. So your inners and your outers cancel out. So if you do FOIL, you're really just kind of wasting time. You should recognize I've got the same terms in both of these binomials, opposite signs, so it's a sum and difference pattern. I'm not going to have a middle term. Okay, I'm going to square the first terms. Basically, Multiply the first terms, multiply the last terms. That's the only time that you can do that, though, is whenever you have a sum and difference pattern. I'm going to watch you guys do that on so many other things, okay? Do not do that here. You cannot just say, oh, square the first term, square the last term, okay? So I find it's helpful if I really threaten you guys. So just imagine me strangling you every time that you have something like this and you decide, oh, I'm just going to square the first term, square the last term. Can't happen on a square of a binomial. Okay, I'm not really going to strangle you, so don't go tell your parents I'm going to strangle you. But just imagine that I'm doing that, okay? Like Homer Simpson does to Bart Simpson, okay? The sum and difference pattern is the only time where you can just multiply the first terms, multiply the last terms. That's the only time. If you need to write more notes on here, do that. Okay, so I notice it's a sum and difference pattern, so I'm just going to multiply the first terms and multiply the last terms. Voila, I'm done. Oh my gosh, that was so quick. Except for all my threats and everything. Sorry about that. But I find it actually works. Okay, again, many years doing this, and if I threaten children, they seem to remember, oh yeah, you can strangle me if I do that. Okay, so here we are. 5a plus 2 squared. So notice I have a binomial squared, or the square of a binomial. So again, you can't just take this first term and square it and take the last term and square it. That is like, Homer to Bart. Okay, not happening. That is not good. That is very bad. Math jail for you. Okay, instead I realize, oh, it's a square of a binomial. I'm going to end up with a trinomial. I'm going to take the first term. I am going to square that. But I am going to have a middle term. And that comes from multiplying the two terms in the binomial, multiplying those two terms, and then doubling it. Okay, so that's what I'm going to do now. So first term does get squared. So 5a squared, well, that's really 25a squared. Middle term comes from 5a times 2, which is 10a, and then doubling that, which is 20a. And then the last term comes from just taking that last term, so back up here, last term, squaring it. Okay, so 2 squared is going to give me 4. And voila, we're done. Look how quick that is, right? If you know these special product patterns, it's going to make your life simpler when you're multiplying, and it's also going to make your life simpler when you're factoring. Because you might look at this and say, oh yeah, that's a square of a binomial, right? This is a perfect square trinomial, which when I factor it, will give me the square of a binomial or binomial squared. All right, let's go for this. So C, I've got 2m minus 3 cubed. So this is the cube of a binomial. So you have two ways of figuring this out. One, you can memorize this pattern. You can write it down on your index card. You can always reference your notes. Or you can recreate Pascal's triangle and realize it's actually the fourth row down because the first row is x to the 0. So you need to go fourth row down. So don't forget about 0. Okay, so you need to go to the fourth row down, and then these will be your coefficients. All right, so I'm going to take my first term, just like here, and I'm going to cube it. Okay, now the coefficient is originally 1, but when I take 2m and I cube it, I'm going to actually end up with 8, okay, eventually. Okay, but imagine there's a 1 out here, and that comes from the coefficient there or the coefficient here. Okay, so it's subtraction, so that means I'm alternating signs. I start positive, then negative, then positive, then negative. Okay? All right, so next is going to be negative. I've got a coefficient now of 3, or you can look here. And then I guess I should probably break up what A and B are, right? So I guess I should focus on A is in fact 2m, and B is in fact 3 or negative 3. I'm just going to focus on the 3 because I already know what the signs need to be. They need to alternate, okay? Okay, so this is going to be 3 will be my coefficient, and then I'm going to square A, right, because A originally was cubed. So I'm going to square A, and then B gets one more power, so B gets thrown in there. So times 3. Okay, next term is going to be positive, and the coefficient that I need is going to be 3. You can get it from here, or you can get it here. Now I'm going to multiply it by A to the first power, right? A gets one less power. And B gets one more power, so now B is squared, so now we have 3 squared. And then again, the signs are alternating, so it's positive, negative, positive. So my last term will then be negative, and it's going to be the B cubed, right? A is all the way down to 0 power, so it doesn't do anything, and now we just have B cubed, which is 3 cubed. Okay, so simplifying this, 2m cubed is really 8m cubed. Okay, remember, you have a product here being raised to a power, so that power gets given to everything inside the parentheses. All right, I'm going to take these numbers outside the parentheses, I'm going to multiply those together. That's negative 9. And then this is going to give me 4m squared. Now, maybe you can do that all in one step, but I want to make sure that I'm giving everybody quite a bit of explanation here. So now I have 3. And 3 squared, well, that's really 9, right? So this is really 27 times 2m. And then negative 3 times 3 times 3 is 27. Okay, so my final answer, I'm going to end up with 8m cubed. This gives me a negative 36m squared, a positive 54m, and a minus 27. And we are done. And I guarantee you, you could go ahead and multiply this 3 times. You're more than welcome to do that. It's going to take you longer. But if you get really confused, hey, that's your fallback. Okay? Let's do one more just to really make this confusing for you. How about that? Just kidding. It's not confusing at all. This is very, very awesome. You guys are going to get this, no problem. All right, so still I've got a binomial cubed, all right? Or a cube of a binomial. Okay? So I think in some of these it's really important, especially ones that have a lot of variables in them, to recognize, you know, in our pattern we used A and B, so try and figure out what A and B are. So A is always going to be your first term. So A is AB. I know that's weird. And B is your 2 here. Okay, so following the pattern that we have above, let's see, can I zoom out so you guys can see that a little bit more? There, I think that should work for us. Well enough, okay. All right, so I'm going to take A, and I'm going to cube it, right? And the coefficient, again, is 1, which you can look over here and get, or you can look at Pascal's triangle, okay? All right, so I'm going to have, I'm not going to put the 1. I'm just going to put the AB cubed. And it's positive, so all the signs will be positive, okay? So now I add to that. Now my coefficient is 3. Get it from there. Get it from here, okay? So coefficient is 3. A gets 1 less power, so A is AB. So it gets 1 less power, so it's going to be times AB squared. And then B comes into the picture. That actually gets a power now. So it's B to the first power, or 2. Coefficient, again, is going to be 3. A gets 1 less power, so it was AB squared, and now it's just going to be times AB. And now B gets 1 more power, so times 2 squared. Am I going to run out of room here? Let's see. Probably not. I can do this. plus, now my last term has a coefficient of 1, which you can see at Pascal's triangle. You can see in the pattern up here. And I'm just going to take b, and I'm going to give it all the power, right? 3. Okay? So now simplifying this, well, again, I've got a product here, so this is really a cubed, b cubed, plus my coefficient here and this 2. Those get multiplied together, so that's going to give me 6. And then I'm going to have an a squared, b squared. Add to that, okay, so let's see. So this over here is 4 times 3. That's going to give me 12. 12ab plus 8. All right, well done.